Hi, we're talking about Chapter 6, Section 7, the quadratic formula, which in theory is review, but I found a lot of people look like they're learning it for the first time. So kind of where have we been, where are we going? If we're looking at a parabola, so I just made a parabola that opens down, kind of moved to the right and up something. When we did the notes earlier, and we looked at the vertex form for a parabola, really the point was finding this high spot. So if this here would be a ball that was thrown upward, and then comes back down, the x value would tell you what time, if this is a height versus time graph, what time is it hit the highest point, and the y value would tell you what is the highest height of the vertex. So that's kind of what we were doing before. The new thing now is trying to figure out, well, what's that point right there, the x-intercepts? And for an example like that, it would be, well, when does the ball hit the ground? Or just for any parabola, when does a parabola cross the x-axis? You can also use this to find any height in the parabola. So if you know the height is, say, this y value, you could figure out, well, what are the two x values that has that height? And we'll do that with a second example. But moving on then, a quadratic formula, here's the actual theorem, I guess they'd call it, that they say if ax squared plus bx plus c equals 0. So in other words, if you have a parabola, that's parabola in standard form, if that equals 0 and a does not equal 0, we'll see why that's the case in a second, then, and here's the actual formula. And this part in here is what I really want you to memorize. If you know that, great, but this is really what you need to be able to do. The x values, so the two x-intercepts, are going to equal negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And that's important for you to know. That's going to be one that I ask you to know going into the test. So like the other ones, write it out when you do the homework, more likely to get it right, and you'll know it before the test. Okay, so the a, b's, and c's in here are really just the coefficients. A is going to be what number is in front of x squared. B is what number is in front of x. C is what number is by itself. Two examples, and then we'll be done. So example 1, if I have a parabola with the equation y equals 10x squared minus 13x minus 3, and that has to equal 0. Actually, I missed a line. Bummer. Okay, one thing that's really important that I want to emphasize is that right there, that in order to get this to work, you have to take, before you put the a, b's, and c's in here, you have to make sure that your parabola equals 0. And that's going to show up in one of our two examples. So I want to write that out. I'm going to put a little star by it because that catches people unawares every year. So only works when one side of the equation equals 0. So it only works if you have your parabola equaling 0. And example 2 looks into that a little bit more. So two examples. First one is just a straightforward, here's a parabola in standard form. So example 1, 10x squared minus 13x minus 3. I put the equals 0 there. You could, if you wanted to, say what are the x-intercepts for a parabola, colon, or for this parabola, this equation, something like that. Alright, so first thing, let's go through and write out the quadratic formula. So x equals negative b plus or minus square root of b squared minus 4ac all divided by 2a. Now as I go through and fill in numbers, I think it's easier personally to just off on the side quickly write out what are a, b, and c. It's a little bit more work to do the writing, but it's nice to not have to keep going back and do you mess up on the signs or that kind of stuff. In case I'm losing you, I'm just going to quick write this in. So our standard form was ax squared plus bx plus c. So now then you see a has to be positive 10. B is kind of the tricky part because it's plus bx, but here we have a minus 13. So b is going to be negative 13. And c then, it's bx plus c, so this minus 3 here It's going to be plus a negative 3, so c is negative 3. If you write this out, you can really ignore the whole problem and just take this and plug these numbers in. So we have x equals negative b, so now I have negative of negative 13, or the opposite of 13. So that just ends up being a positive 13. I wanted to do one with a negative b specifically for this reason right here. We should have talked in class by now that if you take a negative number squared, because this here is going to be a negative 13 squared. So negative 13 times negative 13 is positive 169. I should have mentioned in class, if you don't put the parentheses in, your calculator is going to actually do it from right to left. So it does 13 squared, then applies the negative, gives you negative 169. So you have a couple options. One, put it in parentheses, and then have your squared. That forces it to square the negative 13. When nobody's watching, I just write it as 13 squared, or 169, just quick do it in my head. But make sure that you don't just type in negative 13 squared and then get the wrong answer. Okay, so minus 4 times a, which is 10, times c, which is a negative 3, all divided by 2a. Now, in a couple sections we're going to see why it's advantageous to not type in all this at once. But I'm going to, at least for now, say 13 plus or minus, and figure out what really should be in that radical. So if you have a calculator, use it. Otherwise, this is 169. The two negatives is going to make it plus. We have 169 plus 12 times 10, so 120. So 289. So my radical's a little bit long there. Oh, I didn't fill in a. That's embarrassing. Let's see if I can erase that. So a in the denominator, 2 times a is 2 times 10. So I'd have all of that over 20. And 289 should work out nicely, although that one I don't know in my head. So square root of 289 is 17. So I have here my x values, my x-intercepts, are 13 plus or minus 17 all over 20. And now most parabolas, if I go back a page, cross the x-axis in two spots, which then is where the plus or minus comes in. We're going to have two answers. One is going to be 13 plus 17 over 20. And the other one is going to be same thing but with a minus. So x equals 13 minus 17 all over 20. So I end up with 30 over 20, which will be 1.5 or 3/2. And then here I have a negative 4 over 20, so that should be negative 1/5, or negative 0.2, and maybe negative 0.2. So then those would be the two answers. One x-intercept is going to be a positive 1.5, and one x-intercept is going to be a negative 0.2. So that's one example. I have one more example. If that totally makes sense, you're welcome to just go dive ahead, but I would watch the first part of this example. So the first part of my example here, example 2, when is the ball 500 meters high if its height is given by, then I have a height equation in here. So with this one, if you, so make it bigger that way, okay. So the first part, if you know what you're doing for quadratic formula, great, skip it, except for I would do this, that we're saying the height equals 500. And the point I'm trying to make by putting this example in here is the comment I made before, that it has to equal 0. One side has to be 0 if you want it to work in your quadratic formula. What we're really, well, okay, so in other words then, to make it equal 0, we have to subtract 500 from both sides. So my new equation is going to be negative 4.9 x squared plus 100x minus 485. And now that equals 0, so we can go ahead and attack it with the quadratic formula. In doing that, a is going to be, okay, so if you know what you're doing from there, skip it. If you want a little bit more practice, here's a second example for the quadratic formula. So a is going to be negative 4.9, it's the number in front of x squared. B is going to be positive 100, and C is going to be negative 485. So then I could jump over to my quadratic formula. We'll switch colors and say x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And because we have this negative 4.9, it's not going to work out quite as prettily, if that's a word, as last time. And we have some bigger numbers, which is going to give us a little bit of ugliness. So 100 squared, that's my b, minus 4 times a. I'm going to put a in parentheses just so the times and negative with the decimals and all that doesn't get too confusing. Times c, which is negative 485. Definitely going to need a calculator on this one. All divided by 2 times a negative 4.9. And I'll write the x equals, just to keep everything on the up and up. Alright, so I'm going to figure out what's inside that radical. And I have 100 squared minus 4 times negative 4.9 times negative 485. And so that's going to end up being a positive 494. So I'd have x equals negative 100 plus or minus square root of 494 all divided by negative 9.8. In the notes for tomorrow, the imaginary number stuff, we talk about how, if you have a radical like this, how do you take and simplify that without there being a decimal? And that's a skill that's going to come up over and over later on this year in future chapters and pre-calc and so on. You really just can't get away from it. For now, we're just going to write the decimal. And I punch that in. Square root of 494 is 22.23. I'll do a little bit of rounding. So 22.23. All divided by negative 9.8. And this parabola is going to cross the axis in 2 spots. So first one we have the plus, negative 100 plus 22.23 divided by negative 9.8. My second one, so or, being union, the other is negative 100 minus 22.23 divided by negative 9.8. And if you want to punch these in a little bit faster of a way, you can just punch it in with parentheses around the numerator. So parenthesis negative 100 plus 22.23 and the parentheses divided by negative 9.8. And I get 7.94. And the advantage of typing it in all at once with the parentheses is now I can say x equals 7.94. Or this one here is identical, so I put parentheses there. Except for that minus sign. So I'm going to end up typing in the same exact thing. If instead I do second enter, I get the equation from before. I can just go over to that plus sign and change it to a minus sign. And I get 12.47. So it can save you a lot of typing in these really ugly ones. X equals 12.47. And that's how to do the quadratic formula.